On August 21, 2019, NASA's NICER telescope on the International Space Station observed its brightest X-ray burst to date. The flare-up came from SACS J1808, a binary system about 11,000 light-years away. Here, a pulsar, a rapidly spinning neutron star, draws gas from its companion, an object called a brown dwarf that is larger than a planet but less massive than a star. Hydrogen gas from the brown dwarf forms an accretion disk around the pulsar. Every few years, the disk becomes unstable. This sends a rush of gas toward the pulsar that makes it brighten in X-rays. The pulsar's super strong magnetic field sweeps up the gas and channels it to the object's surface. Hydrogen nuclei falling to the pulsar's surface fuse together, producing energy and forming helium nuclei, which settle out below. This process is similar to what happens inside our Sun. Then, when the conditions are just right, the entire helium layer ignites in a brief but intense thermonuclear fireball. Astronomers call this a Type 1 X-ray burst. Here's how it happened. The explosion first blows off the hydrogen layer, which expands and ultimately dissipates. Then, the rising radiation builds to the point where it blows off the helium layer, which overtakes the hydrogen shell. Some of the X-rays emitted in the blast scatter off of the accretion disk. The fireball then quickly cools, and the helium settles back onto the surface. It was all over in 20 seconds, but NICER data clearly show important details that haven't been seen together in other bursts. This will help scientists better understand the extreme physics of these eruptions on accreting neutron stars.